Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and I am excited to have the privilege of doing this video with you. So, what I'm going to have a look at specifically today is video 5 of 5. This freebie, the one that I gave to you for Mahala, means zero. It costs you nothing. Hopefully, this costs you nothing. But, ladies and gentlemen, today we're going to specifically have a look at roots, because what I have found in my experience is that learners, the moment they hear roots, they go delta. Woo! I'm gonna look at delta because delta, I'm looking at roots, and sometimes the examiner actually don't want you to look at delta. So today we're going to have a look at roots, and what must we think about with roots? What is our end goal when we are talking about the roots of equations? So buckle up, have a wonderful time with me today. Now, roots, ladies and gentlemen, are the solutions to equations. It doesn't necessarily have to do anything with delta. It's the roots, it's the solutions to any equations. So in other words, it could even be a cubic. It could be a parabola. It could be exponential. The roots are the solutions to equations. So when we specifically talk about roots, I don't necessarily have to go towards delta at all. So if I look at this very easy sum and I ask you, what are the nature of the roots? Meaning, how do the roots look? Tell me, describe, paint me a picture of what the roots are actually like. Let's solve it. I'm going to do it differently. So let's take it over and make equal to 0. Factorize. So x is negative, or x minus 4, and x plus 1 is 0. So x is 4, or x is negative 1. So what are the nature of the roots? Well, simple. First of all, there are two unequal roots. The roots are definitely real and they're rational. Ta-da! I've answered the question. Now you might go and say, yeah, sir, but why don't we use delta? Well, we can. Definitely, in this scenario, we can use delta. So in other words, I could just as well, once I've got equal to 0, go towards delta as b squared minus 4ac, substitute b with negative 3, a with 1, and c with negative 4, and I find that delta is equal to 25. Now that is first of all bigger than 0, and it's a perfect square, so our theory says that there should be two unequal roots. It's real. And because it's a perfect square, it's rational. Oh, so much easier to do delta. That's the truth. It's the truth. But I'm doing this video specifically because I want to kind of do a mind shift on you to kind of think further than just delta when you hear the word roots. Roots are solutions to equations. So I'm going to throw in a nice little exam type question that I've seen before because I set up an exam similar to, or that had this question in it. Now, the question asked the following. Determine k if the roots of 3 to the x minus 9 and kx minus 1 equal to 0 are equal. So determine the root. Determine k if the roots are equal. Now, if you're going to go towards delta, all I'm telling you is good luck. Because no matter how you slice your cheese in this one, no matter how you multiply it, you will not get a quadratic equation. So let's actually look at what they tell me. They tell me the roots are equal. So in other words, the answer I get from the first fraction or the first bracket must be the same as the answer I get from the second bracket. So in other words, if I look at how I'm going to approach this, I'm going to get my solutions and put them equal to each other. So 3 to the x minus 9 equal to 0. That's the one possibility. So now we solve it by getting the bases, or getting the 3 to the x on one side. Make the bases the same, and x is therefore 2. But now that's just the first bracket. Let's look at the second bracket. Now, because of the zero product rule, the first bracket times by the second bracket, 0. Both brackets equal to 0 are solutions. So kx minus 1 equal to 0 is also a solution. But now I'm telling you there is only one solution. So in other words, k is actually 2, or x is 2, I mean. So let's substitute in. K times 2 minus 1 equal to 0. So now let's solve for k, and therefore k is equal to a half. There, I've got it. Ladies and gents, if you just thought about delta, this would be completely not solvable. So I'm encouraging you, do not just when you hear the words roots, think about delta. So where do this apply? Where do they ask me these kind of questions about roots and that? And to give you some advice, they first of all give you, when they ask you about the applications, they love to ask the applications inside graphs, specifically parabolas. Because with parabolas, the x-intercepts. Because if I get the standard equation and make it naught, well, that's a normal solution. So when we're talking about the roots of a parabola, it's the x-intercepts. When we talk about other kinds of equations with graphs, actually, intersection between two graphs, especially a parabola and a straight line. If it has two unequal roots, it means the graph intersects twice. If it has one root or equal roots, well then the graphs touch each other. They don't cross again. So the one graph is a tangent to the other one. If they say or no real roots, it means the graphs do not intersect. Awesome when you start thinking about it. And of course, anywhere where you can find graphs or equations, we put them equal. We make them equal to naught. Wherever you can find an equation in mathematics, I can talk about roots and not actually refer to delta. So my encouragement to you is, go and rewatch this video. Go and practice. Find those beautiful questions. But remember, yes, you can think about delta when we talk about nature of the roots. But you can also just think about solving those equations and looking at them and say, but this is the nature of the roots. So as we finish off this last lesson, we are going to just quickly do a recap. First of all, we started with quadratic equations. Then we moved over to exponentials and surds, where you've got to always remember to test your answers. And with exponents, you've got to be careful when you introduce your own exponent. Then we went over to inequalities. Oh, some of you guys are still having headaches about it. Please remember to rewatch that video. Practice, download that worksheet with a memo and make sure that you get, the sums 100% right. And if you are still struggling, go and see a teacher, go and see a tutor, or mail me. You are more than welcome to. Ladies and gents, it's been a fantastic first cycle. Remember to subscribe to our Junior Tukkies YouTube channel. Remember, if you haven't yet, go and register on our Google Classroom so you can get all the updates when there's something new coming. In our next cycle, we are going to specifically have a look at functions and graphs. Oh, I love functions and graphs because they're so applicable everywhere. Ladies and gents, this is Sarah van Grennen, aka Mr. VG. I'm signing out. See you again soon. Cheers.